Hey guys, welcome to the first ever episode of SBL Learning. Today we're going to be talking about first principles, so let's get to it. So the first thing about first principles, it is the first thing you learn when starting to do calculus and derivatives. So basically we're going to step right in and see if we can make the equation ourselves. So the first thing we want to do when using first principles is really, what do we want? What we want is we want to find the tangent line to the curve, right? And so basically, like any linear line on a graph, this is going to have a slope, right, equal to some m, let's say. And so what we're trying to find is the value of this slope using first principles. And so basically how we're going to do this is we are going to use some of our grade 9 math. So let's pick 2 points. Let's call this point 1 and this point 2. We can see if we connect point 1 and point 2, we get a line like this, right? Where, point 2 has x2, y2, and point 1 has x1, y1. And so we know the slope of this line right here, the slope, right, would be equal to y2 minus y1 over x2 minus x1, right? And that's rise over run. So that's pretty much just your high school slope equation. And so what we're going to do is, if we want an instantaneous tangent line, so if let's say I wanted the tangent at this point, right? Not in between 2 points. I wanted the tangent at a given point, right? Basically what I'm going to do is I'm going to pretend like I have 2 points, right? And the more and more I shrink these 2 points together, I'll get an instantaneous point. Cool? So that's when x2 equals x1. So basically what we're doing is we're going to assume that x2 and x1 are approaching 0. Cool? So then I can say, let's call x2 minus x1 the distance between our two x's, right? This being x1 and this being x2. I'm going to assume that they're going to get closer and closer and closer together. So I'm going to define a variable h that's equal to x2 minus x1. So now our slope equation, cool? Now our slope equation is equal to y2 minus y1 over h. And so what we can do here with this slope equation is, we know this function h of x, right? The y value, we can rewrite our points, right? If we have x1, our y value is just h of x1, right? And for point 2, right, we would have point x2 and h of x2, right? Because when you plug the x into the function, let's say our function is like, h of x, let's say up here, is equal to x squared. So h of 2 would be 4, etc. So basically whatever this x2 is, we plug it into our function. Now what we're going to do is we're going to replace our y2 and y1 with these different representations, just a different way of writing it. Simple notation. So now our new slope, cool, is equal to y2 is just h of x2 minus y1 is h of x1, cool, all over h. One thing I'm going to do to make this easier is I'm going to call this function, instead of h, I'm going to call it g of x, just because you don't want to have the same variable, just because it can get confusing. So h is still the difference between x2 and x1, but up here we're going to write g. Cool? We have slope x2, x1, and h, too many variables, so we want to get rid of some. So basically we can write x2 in terms of x1 and h. If we reorganize this equation, we can bring over the x1 over this way. That equals to x2. So where we see x2, we're going to put this inside of it. So now our new slope is going to be equal to g of x1 plus h minus g of x1 all over h. And so you can sort of think of this as the g of x1 plus h, right? If we have this function, if this is g of 2, let's say, right, g of 4, right, would just be g, right? G of 4 is the same thing as g of 2 plus 2. That's basically all we're writing here. It's the value of x1 plus the difference between the two gets us the point where we want to be. And what we want to do is we want to shrink this as close as possible. So to get instantaneous slope, what we have to do is basically this h value, the difference between x1 and x2, is going to approach 0, right? And then we get the same point. So let's say this was x1 and x2, and we keep shrinking and shrinking and shrinking until we're at a single point. And that's basically what we want to do here. So in general, our slope equation, or our first principles equation, FP, right, is going to be equal to the limit as h goes to 0 of g of x1 plus h minus g of x1 all over h. And so this right here is our first principles equation. And that's how you can remember it, where h is defined as the difference between your two x's. So I hope you liked that video. If you have any questions, please leave them down in the comments and I can try my best to answer them. I'm going to be posting a few example videos using first principles to find the derivative of some equations. So watch out for those coming up in the future. If you have any other topics in math or science that you're struggling with, please also post them in the comments and I'd be happy to make a video about them. Thanks.